Hello, everyone. Good morning. I think we have some people joining us. Welcome, everybody. We'll just wait a couple of minutes while everybody joins the call. Thank you for joining. I'll just introduce myself while we're waiting. My name is Yara Shenafapon. I'm part of the one of the projects today that's presenting Dryad, but I'm also here as part of the MIPFA Adapt, which is the implementation team for the EU mission on adaptation to climate change. I work at a Catalyst. I'm based in Madrid, and yeah, it's really nice to be here today with everybody. Hopefully you can hear me okay. I think we'll be monitoring the chat if anybody has any technical issues. But yeah, we'll just wait another minute or so and see and let some people join the room. Welcome everybody if you're just joining, and thanks for joining us today. Hopefully everybody's having a nice day, nice Friday. Great. So I think everybody can see the PowerPoint, hopefully, which we're sharing. Is that visible for everybody? Yep. Okay, so any issues, please type in the chat. And I think, yeah, we'll get started. So again, thank you so much for joining us and welcome to this session on nature-based and systemic climate solutions. This is going to be a showcase of results and information from a series of projects in the topic of nature-based solutions in agriculture, part of Horizon Europe. And I'm going to be facilitating this session. My name is Yara. So yeah, welcome everybody, and yeah, thanks for being here. So maybe we can start. If we could have the next slide.
We don't see the presentation.
Oh, okay, I see it.
I see it too.
Oh, okay. Please go on.
Okay, I'm getting some thumbs up, so hopefully we can continue. Great, so yeah, I'm just going to briefly welcome everybody, so thank you for joining us, and give a bit of information about the session, why we're here today, before I give the floor to all of our invited speakers. So if I could have the next slide, please. So we're here today as part of EU Green Week, which you might be aware of. I know there's some events happening in Brussels and also online, and also with World Environment Day. So happy World Environment Day to everybody. And just a bit about the projects that we're going to be seeing today. So if you're not aware, within the kind of EU funding scheme, we have this thing called sister projects. So these are 4 sister projects. We are a cluster of research and innovation projects dealing with similar topics across Europe, and you'll hear from the speakers in more detail in a moment. So as sister projects, we've come together for this EU Green Week, and we've partnered within this World Environmental Day event to give a bit of an overview of a common goal that we are all investigating and working on, which is advancing climate adaptation and resilience in agriculture across diverse European regions. So a lot of these, or all of the projects, work around Europe in different geographic and climatic regions. So you'll hear a bit about different regions across Europe and the work that's being done. So we have 4 projects here today: Klima Pannonia, Transform, Resilience, and Dryad. And we're going to have speakers from each of the 4 projects presenting some results, and then a chance to discuss with the speakers as well. So next slide, please, Laura. So as I mentioned, the projects are funded under one of the EU missions. So if you've not heard, the EU has 5 missions on supporting research and innovation in key areas. We are funded by the EU mission on adaptation to climate change. So this mission is focusing on supporting EU regions, cities, and local authorities to build resilience against the impacts of climate change by 2030. It is a catalyst for coordinated climate action across Europe. And the main goal is to bridge the gap between the scientific knowledge generated by all the different projects that are funded by the mission. Currently, we have around 65 projects funded by this mission, and support the implementation and the connection of that research work with policymaking and local action across Europe's regions. So this is part of the kind of cross-regional climate resilience action that's happening in Europe, both within the mission, other missions as well, and also a very important network and resource, which is Network Nature, specifically for the nature-based solutions community. So I invite you to have a look at both of these. We can share details at the end. Network Nature is, as I said, a community and a collaboration space where we can share knowledge, strategic action, and try and maximize impact from all the nature-based solutions that are being researched and worked on across Europe. Network Nature also has task forces on specific topics linked to nature-based solutions, and it connects more than 100 EU-funded NBS research and innovation projects, including Horizon 2020 and EU mission initiatives. So if we can have the next slide, please. I'm just going to run through the agenda for today. So I've done the welcoming. We're now going to have some time with the project pitches, as I mentioned. So we'll have a speaker from each of the topics of each of the projects, from Klimapannonia, Resilience, Transform, and Dryad. After the four talks, we're going to have around 10 minutes for Q&A. Hopefully you should see a Q&A function. I'll explain that in the next slide. So if you have questions, you can type them and then we will come to them in the Q&A. We're then going to have an hour of panel discussion on cross-regional synergies for climate adaptation with 4 different topics, where we will be asking the speakers from the different projects to give their insights on these topics, and also you in the audience will have a chance to ask questions about the topics before we wrap up and close. So next slide, please. Just a bit of information on the webinar. As I mentioned, there'll be an opportunity to ask questions after the project pitches. So please use the Q&A. If you have any questions or you can't find the Q&A, I think it should be at the top of your Teams bar. Then you can use the chat and one of the team will help you find the Q&A function. So submit your questions as they come and as we go through the talks. When you do so, please do say, in brackets, which speaker or which project you would like the question to be aimed at. So that will help us at the end to go through the questions in the Q&A. And then in the panel discussion afterwards, again, if you could say which topic your question is for, then we can come to it in that section. The session is being recorded. We'll share details at the end of the talk, but it will be available on the social media channels of the projects, and I think will be shared by email as well. So if we can go to the next slide, we'll start with the project pitches. And the first project is Klimapannonia. So Klimapannonia is going to present on results, the first results from the project on climate resilient agriculture. And we have 2 speakers from Klimapannonia. So we have, and again, if maybe I'll mispronounce people's names, you're welcome to reintroduce yourself correctly. But Maja Budimir, Maja's project manager and communication lead in the Klimapannonia project, working at the Association of Balkan Eco Innovation. Maja is an environmental engineer and works on several EU-funded initiatives with a focus on climate action, sustainability, and stakeholder engagement. And we also have Sveltana Vujic, who is associate professor at the University of Novi Sad in the Faculty of Agriculture. And Sveltana is the demo leader in Klimapannonia for organic production. As I mentioned, the associate professor at the University of Novi Sad, specializing in forage crops and grasslands, and working on the organic crop production demonstrator in Klimapannonia. So if I can give the floor to Maja and Sveltana, then I think you have around 8 minutes for your talk. Thank you.
Thank you, Yara. Hello, good morning, everyone, and thank you for joining us today. We are pleased to open this project pitch session by introducing the Klimapannonia, the youngest project today in the group, but one that shares the same, let's say, overall ambition with the other projects in this session. So building the climate resilience through practical, systemic, and scalable solutions. And nomen est omen, so as the name suggests, Klimapannonia focuses on the Pannonian region, one of Europe's important agricultural areas, but also a region increasingly exposed to climate risks. So next slide, please. You may see the map of the Pannonian Basin, the region, and but the full name of the project is you can see the building climate resilience via large-scale uptake of systemic solutions in agricultural ecosystems in the Pannonian region. But the story itself starts with the challenges, of course, that are already visible across the whole region. So severe droughts, changing weather patterns, uncertain rainfall, soil degradation, and increasing pressure on water resources. So these challenges are not unique, of course, to our region, but as we will also hear from the other projects today, many European regions are facing the similar pressures. What differs is the local context, and this is why region-specific and practical systemic solutions are so important. So the core objectives of Klima Pannonia are therefore focused on three main directions. So strengthening the climate resilience, the resilient agriculture, supporting systemic innovation and knowledge exchange, and fostering regional collaboration. So this is demonstrated in Klima Pannonia. This is demonstrated through key subsectors of interest represented by 4 deep demonstration sites, the water food nexus in Hungary, agroforestry in Hungary as well, so organic crop production at Rimski Šamčevi, Serbia, and cattle production in Serbia. Next slide, please. So just shortly, next slide will gives us a more visual impression of the demonstration sites and the types of agricultural systems we are working with. And since this project is not looking at the climate adaptation only as a technical issue, it is also looking at how solutions work in real landscapes with real farmers, of course, local stakeholders and regional specificities. Next slide, please. So the project, as already mentioned, the project explores 4 key areas. In each of these areas, climate-adapted practices are tested, refined, demonstrated through a network of deep demonstrators. So 4 deep demonstrators in Hungary and Serbia, but together with the reapplication demonstrators as well. We have 8 reapplication demonstrators, 4 in Czechia, 2 in Romania, 1 in Serbia, and 1 in Croatia. The innovations we are working with include, of course, smart water use, drought mitigation, agroforestry solutions for sustainable berry production, nature-based solutions for large-scale organic crop production, and approaches for mitigating the climate impact of cattle production. What connects all of these areas is the systemic approach. So we are not looking at isolated practices, but at combination of solutions that can respond to real climate-related agriculture. So you can see the impact that we are actually running for are the action-based regional roadmaps, then sustainable business models, innovative financing models, trainings and workshops, and finally, of course, the Klima Pannonia digital application. So next slide, and Svetlana, please.
Thank you, Maya. Good morning from my side. And as Maya also mentioned at the beginning, that we are a very young project, so we have little bit more than 1 year from the start. So therefore, we have very early results and insights. And firstly, it's setting up the systematic solutions implemented at 4 deep demonstration sites within 4 agriculture subsectors. So those solutions will be demonstrated and validated as a potential to enhance climate resilience and adaptive capacity across diverse agroecosystems. Furthermore, we started with working on replication of those solutions within 8 reapplication sites. The important thing here is that 4 reapplication sites are within and 4 beyond Pannonian region. So it's going to confirm strong scalability and potential of those provided solutions. Another very important point of this project is definitely Klima Pannonia digital application. And this application will be a platform for monitoring, evaluation, of course, knowledge sharing of these solutions. And currently, the process of data collecting is ongoing. And if we are talking about the knowledge sharing, the stakeholder engagement is also a very important aspect of this project. Through stakeholder engagement activities, they enable to co-create and to validate all solutions that are proposed. And the final point here that is mentioned is definitely, and is under development, are business models and national roadmaps. So to these parts of the project are also important, having in mind that they will facilitate long-term adaptation of proposed measures, of course, policy integration and large-scale implementation. So having all said, we can point it out that these definitely early results and insights that Klima Pannonia project have is combines like a scientific approach, but also stakeholder collaboration, digital innovation in order to create more scalable and sustainable pathways for climate resilience. So that's for the Klima Pannonia team.
Great, thank you very much for that first presentation. Super interesting to see what you're getting up to. If anybody has any questions for Klima Pannonia, then put them in the Q&A, please. If you can't find the Q&A and you want to use a chat, then also do so. Okay, great. So we will go on to the next project then. So now we're going to have a presentation from the Resilience Project from Petteri Karisto. Petteri is Senior Scientist in Plant Health at Luke Natural Resources Institute, Finland. And he's a Resilience Project Coordinator. Petteri is an agricultural plant pathologist with a background in theoretical ecology, and his research topics cover epidemiology of fungal plant pathogens, especially in horticultural systems, as well as all the work going on in the Resilience Project. So Petteri, if you go ahead, the floor is yours.
Thank you very much for the introduction, and thank you very much for the organizers for setting up the meeting, and equally to all the participants for joining us, and also to people who are watching us afterwards. So my name is Petteri, as you heard. I'm leading the Resilience Project, which is focusing on Boreal region. As you may know already, all the sister projects have their own biogeographic region where we are focusing, and Resilience is working in the Boreal region. And we are strengthening climate resilience in Boreal agriculture and forestry. The role of forestry is kind of a specialty for us because Boreal region is characterized by forests, and Finland is most forested country in the EU, and similar trend is true for other participating countries. But overall, we demonstrate systemic climate resilience, which might not be a surprise. Resilience name comes from precision climate resilience for agriculture and forestry in the European Boreal regions. And the core activity for us is the practical demonstrations of climate adaptation solutions or climate resilience solutions in our region. And we are focusing on proven solutions, things that have already shown to be functional, delivering the effects that we want. And we want to advance the uptake of those, adoption of the best practices and utilization of the solutions. Besides the practical demonstrations, we are doing a lot of enabling, supporting, optimizing, and upscaling activities, which cover things like co-creation. We do climate impact and adaptation analysis with our stakeholders. We are mobilizing stakeholders in broad sense throughout the system, and we are doing a lot of collaboration and knowledge sharing within the regions and between the regions. Next slide. So we are playing on this area in Finland, Sweden, Norway, Estonia, and Denmark. And we have a really nice set of partners, 16 partners in total, covering research organizations, regional authorities, companies, NGOs, advisory services, so on. For agricultural demonstrations, we have about 40 sites. Overall, we are working on diversification of agricultural production, using of cover crops, water management in agriculture, tillage practices, soil improvers. And for the forest demonstrations, we have over 200 sites where we are measuring and demonstrating effects of management, risk and resilience in boreal forest, regeneration practices, species selection, and so on. Next, I will show you a few examples of the demonstration sites. So here you see the agricultural demonstrations. Diversification on the left, we are using different tools and decision-making support systems for optimizing and diversifying the crop rotations or selecting optimal production plans for different patches of field. On several sites, we are demonstrating different drainage practices for optimal drainage, but also water retention in the agricultural soils. Lack of water has not been traditionally a problem in the boreal region, but it's coming up now, and especially early season droughts are really damaging to our spring sown crops. We are applying different soil improvers. These are such as biochar or pulp mill sludge that can enhance the properties of the agricultural soils. These are already in use in large scale on certain regions, but on other regions they are not so well known and not so much utilized. And we are also demonstrating effects of different tillage regimes on soil health, microbial communities, productivity, and resilience. Next slide. Some examples from forestry site. We are measuring forest structure, demonstrating the effect of forest structure in different regions. We are showing different forest management regimes, how that affects the climate resilience of forestry. We are measuring and demonstrating forest regeneration practices, showing what works, what kind of risks there are, what is possible in our regions. And we are paying close attention to forest damages. We have already identified one novel pathogen to Finland during the resilience project, which is of course unfortunate, but shows the value of the work that we are doing. Next slide, please. I also mentioned the enabling activities besides the demonstrations, and now I will tell a bit more about those. On the right, you see our focal regions more in detail. So we have 11 regions in total in the 5 countries. We are focusing our activities to these regions and tailoring them to these regions based on the needs of the regions. And to optimize that and to support adaptation, planning, and implementation, we have conducted some 90 interviews and held 11 workshops. So 1 workshop already in each of the regions, where we have discussed climate adaptation, risks, practical perspectives. And results of these will be put into regional climate adaptation narratives, and they will support the regional adaptation planning, building the roadmaps. And we have already prepared an animation Arne's farm that you see on the bottom left. It is a illustrated story about a boreal farmer adapting to climate change. What kind of phenomena there are, what kind of emotions, what kind of solutions, perspectives from the interviews and stakeholder workshops. Next slide. A final slide about the work that we are doing, further enabling activities. We are advancing modeling of risks and adaptations in our regions. We are taking the large-scale models and scaling them down to the regional levels to see exactly what kind of challenges there are to be expected in different regions. Although we are close to each other, there are different aspects particular to each region, depending on the systems that are in place. So we are modeling risks and adaptation to evaluate possibilities for adaptation and also their future potential. And finally, for having a full systemic effect, we are utilizing stakeholder steering groups, which are kind of national boards of stakeholders that are key to climate adaptation. They are participating in our meetings regularly. They hear results from us the first, and they give feedback to us, telling us what kind of results would be most preferred or most useful for them. As you see, we have public authorities, municipalities, public institutions, service providers, farmers, cooperatives and producers, NGOs, investors, banks, insurance companies, industry, and institutional landowners. So we are covering entire system from finance and insurance to practical people that are hands-on in the work. So thanks a lot for listening to me, and we move on to next one.
Thank you. That was really interesting. Thank you so much. Great to hear from the Resilience Project. And please do add any questions that you have for Petteri in the Q&A, so we can come back to them later. Brilliant, thanks. We'll go to the next speaker then. So now we have the Transform project. David Bohan is going to be presenting. David is Director of Research at INRAE, which is a research institute in France, and the Centre Bourgogne-Franche-Comté in Dijon, France. Hopefully that's well pronounced. And as I mentioned, David is the Transform project leader. David is an agroecologist with interest in ecological networks in agriculture, farmer-led engagement, crop rotations as a management tool to improve the delivery of ecosystem services and climate change. And you'll hear much more about all of this in David's talk. So please go ahead, David, and thanks.
Thanks very much, Yara. Good morning, everyone. My name's David Bohan, and as Yara said, I'm a Director of Research at the French National Institute of Agriculture, Agronomy and the Environment, INRAE. I lead the Transform project, and what we're trying to do is innovate new crop rotations. One of the key features of landscapes in Europe is that they are predominantly agricultural. These landscapes are places where we live, where we work, and where we go on holiday. And anyone who's spent any time in them will actually notice that they're quite diverse. There are a multitude of crops being grown across them. And if they come back the next year, they'll see different crops, and the year after that, different crops again. And this is because in each one of the fields that are in those landscapes, there is a sequence of crops being grown by farmers. And this sequence is what we call a rotation, a crop rotation. And this is what we're trying to innovate. Now, this whole process is really important. No, please back one, thank you. Thanks. This whole process is kind of important because these crop rotations give farmers they're economically important and agronomically important to farmers. These rotations also produce the biodiversity, the food, the fresh water, and the organic content in the soil that we as society wants. And so one of the key elements in Transform, in our approach to actually innovating new crop rotations, is to get the balance right, to make sure that farmers get what they want by innovating rotations that are good for them, and that society gets what it needs by making sure that those rotations actually deliver to us the things that we want. Next slide, please. And this starts at the societal level with us attempting to formulate what are called roadmaps. We work with regional governments to set targets and aims for agriculture in the future. We then go to work with farmers. And in working with farmers, we're trying to innovate new rotations. But one of the things that we've found is that farmers actually have a great deal of trouble imagining what future climate scenarios mean for them, how they can actually change their practices. So what we're doing is working with farmers in co-development to actually try to invent new tools that help them innovate new future rotations. And what we hope is that the output of this will be innovative and resilient crop rotations that we can use as nature-based solutions to achieve our goals. Against that, we've developed methods for monitoring and mapping the effects of future rotations so that when we actually do accept them, hopefully we're not going to make too many mistakes in the future, and we can measure any of those mistakes that we make. And we're investigating around that, because these crop rotations are actually the basis of much of the work that farmers do. It's on top of these rotations that they use machinery, use pesticides, and so on and so forth. Is identifying new avenues of research and future research into the future. And so what we're trying to do in Transform is build a whole framework that hopefully we can demonstrate in our demonstration regions in the project works, and then take to new regions and show that it works there also as a way of accelerating innovation across Europe. Next slide, please. So Transform works in the western seaboard of Europe in what's called the Atlantic Biogeographic Zone. We have 18 partners in 8 regions in that zone, and each of those regions contains an academic partner and a practical partner, a partner who works much more closely with industry than the academics. We have 5 demonstration regions in Spain, in France, in the UK, Netherlands and Denmark, where most of this work is developed. We develop our methodologies and approaches. And then we have 3 replication regions also in France, in Ireland and in Denmark, where we take the things that we've developed in the demonstration regions and see whether they work there. In other words, we try to test whether the methods that we have actually will spread to other regions. Next slide, please. And so the first innovation that we're working towards is these roadmaps of adaptation. What we're trying to do with these is to build methods which allow regional governments and regional stakeholders to identify the targets that they have for agriculture in the future. Next slide, please. We're working with farmers using co-development methods to build a tool that allows them to imagine the future. The first version of the tool has just been developed. And what this slide here shows you is, if you like, past weather, the weather that farmers have been familiar with up until today. And then it also presents on the right-hand side of the image, future weather. So they can actually start to compare past and future weather and start to make decisions. And there's an aspect of the tool which also allows them then to play with different sequences of crops and to see what those will do in the future. There's also a picture here of one of the co-development workshops where we actually work directly with farmers to design this tool. This tool is not created by us and given to farmers, it's developed in co-design. Next slide, please. And we then have visualization approaches. And this allows us to take some of the rotations that we've selected as being interesting for farmers and actually project forward into the future what those mean. We have detailed dashboards like the Agriland Viewer, which shows things like biodiversity. It will show things like soil organic matter, and these kinds of visualizations are really good for regional governments, for advisors, and so forth. And as we go and start to talk to other stakeholders, we have things like games which we can actually play with stakeholders like the public to actually start to demonstrate to them things about the future of their landscapes. We can show them in VR landscapes, and we can also put our rotations in things like games. Here there's a small photo of Minecraft. We can actually put these rotations into games and actually people can play within them. And this is a whole aspect of stakeholder engagement that we have in Transform. Next slide, please. And in terms of early results, as I've said, we've developed the first version of the roadmaps, and part of the roadmaps is a methodology for SWOT analysis. And the SWOT analysis allows regions to actually identify the strengths, weaknesses, opportunities, and threats within agriculture in their region. This is a whole part of a process of actually getting them to understand what they actually need and want for society from agriculture in the future. Next slide. We have this, excuse me, sorry, that's my alarm just going off. We have this Future Rotations Explorer tool, which actually demonstrates here, for example, a sequence of crops, what that means in terms of the past, which is in blue, and in the future in purple. And farmers can compare what a particular crop rotation will do in the future. And it allows them to play with that and develop new ones. This is an advance. Next slide. We have a lot of stakeholder interaction, but what we're finding in the current climate is that this is proving to be ever more difficult. Farmers, for example, over the last 3 years, we've seen a lot of pushback from farmers. They're not particularly happy to work. They're oversubscribed, overworked, and they don't want to be involved quite so much as they would have been in the past. And so our internal stakeholders, our internal practical stakeholders are becoming ever more important in this process. Next slide, please. I think that's it. Thank you very much. That's the Transform project.
Brilliant. Great. Thank you so much. Super interesting. And yeah, I'm sure there'll be some questions. You've all posed different questions about stakeholder engagement. I'm definitely interested in how each of the projects is addressing this. So thank you so much, and great to hear from this region. So we now go to the last region. We're moving to the Mediterranean area with the Dryad project. So this is going to be a presentation by Javier Samper Calvete, who is the leader of the Dryad project. He's a coordinator, and he is a professor at the University of Coruña in Spain. Javier is a civil engineer and hydrologist. He specializes in hydrology, hydrogeology, and groundwater modeling, and has conducted extensive research on water resources, contaminant transport, and simulations of subsurface flow. So we're going to hear about this and also about the Dryad project and the NBS that is working on from Javier. Thank you very much.
Okay, thank you, Yara, for the presentation, and thank you all in the audience and also the organizers of this webinar. I want to share with you the early results of Dryad. You may ask yourself, why Dryad? Dryad is the nymph of the forest. Remember, this is the in the Mediterranean region, nature-based solutions for Mediterranean ecosystems, and this is very, very special in Europe, unique landscape, because it involves, as you can see in the picture here, forest. It's a forestry. It's cattle, and there's also agriculture. So it's a very unique setting, and I want to acknowledge the brilliant consortium. I am just the leader, but I am really, really proud of the team behind the Dryad. So next one, please. Next. Okay, now the main challenges that we face in the Mediterranean region, it's droughts, soil degradation, decline in water table, decline in water moisture in the soil, oat tree mortality, reduced productivity, and wildfires. So our vision in Dryad is to connect, integrate, co-creation, stakeholder engagement, monitoring. You need data to prove later that you are improving the system, the ecosystem, and modeling. This is a very unique tool. So to enable quantitative evaluation and then scaling of the MBSs so that you can prove that the MBS are demonstrated. So you can see the map there that we have 5 demonstration regions and in 4 countries, and then these solutions will be replicated in 3 regions in France, Spain, Italy. Again, the challenge is not implementing MBSs, it's demonstrating them in a quantitative way and being able to scale them from pilot area or a farm, scale them into regions. Next one, please. So the approach and the architecture of Dryad, again, is based on co-creation with the stakeholders, and then solutions are demonstrated. But this is a requirement for all the projects. We should be able to create and the way to replicate these solutions in other regions, and then well, on the right, you can see the main parts of the project. At the top is co-creation, but you need, well, with the support of the implementation of living labs, and again, monitoring, modeling. I want to comment the decision support tool. This is essential to connect with the stakeholders, and then again, the challenge of upscaling, not only going from demonstration to replication, but upscaling to regional scale. Next one, please. Now, which MBSs are we dealing with? Well, I will not describe what an MBS is, but in Dryad, we have, as you can see at the bottom of the slide, we started with 40 candidates based on literature. We selected in a first screening 14, and actually we conducted an online survey to identify, and we came out with these 14 MBSs. 2 of them were merged, and then finally, after co-creation and the allocation of MBSs in each one of the regions, then we ended up with 11 MBSs. Let me just, without entering into the details, water-related include the artificial ponds, drainage ditch systems. We have prepared cartoons with, as you can see on the right, for each one of them, indicated in which region they are implemented. Soil-related MBS, wildfire prevention, adaptive grazing, but the use of biochar, real-time livestock monitoring, biodiverse pasture sowing, and finally, biodiversity-related, early detection of tree mortality, natural islands, forestation of agropastoral systems, and protections of trees. Okay, so at the end, 11 MBSs have been implemented. Next one, please. So, okay, next one. Yeah, okay. Let me tell you that Dryad, we incorporate innovative technologies for monitoring. You can see on the right bottom a picture of one of the trees, which is monitoring subflow, the tree talker, meteorological station, soil moisture, and all of this with this LoRaWAN system, which is a low-cost acquisition, real-time monitoring. Innovation in monitoring. We also, all the data for the project is managed with this AgroAcque. You see a window from this AgroAcque software to handle all the field data, remote sensing, model inputs, model outputs. All these data are used to build models which are really sophisticated, starting with the eco-hydrological, including soil, vegetation, atmosphere, groundwater, agroforestry and productivity, fire spread, and also models for the spreading of tree mortality. All of these provide the support for what comes next is the development of decision support systems, which will translate knowledge into decisions. So the final goal is to provide support to stakeholders. And then, so I want to stress again that we move from qualitative MBS narratives to quantitative MBS evaluation. So next one, I will conclude with early results. We have results in terms of the implementation of all the data collection network in 5 demonstration and 3 replication regions, agroacque software. We develop these sophisticated codes to deal with, all the physical, ecological processes. A first prototype of a decision support system. We have produced a co-creation database and also a database of MBSs. And again, 11 MBSs have been implemented in 5 demonstration regions. Main impacts: increased resilience, improved water availability and soil health, enhanced biodiversity, strengthen local and regional governance. Of course, we look for societal benefits and to be able to transfer knowledge from demonstration to replication. To conclude, our purpose trial is to demonstrate that climate adaptation by MBS it requires not only implementing, but it requires quantitative evidence, stakeholder co-creation, and decision support systems and MBS scaling. That's all. Thank you very much.
Thank you, Javier. Very interesting. And thank you very much for showing us around the Dryad project. So we've come to the end of the first session and we now have some time for Q&A for all of the different speakers. We do encourage you to ask any questions you have now of the speakers or about the projects that they've presented before we go into the panel discussion, which will be focused on 4 specific topics. So if you have any questions for anybody, please type them in the Q&A or in the chat. And we have one I'm going to read while you gather your thoughts. We have about 5 minutes if you do want to ask any questions. So the question, resilience, question around the stakeholder steering groups. What was the process to create these steering groups and what recommendations do you have for them to work well?
Our stakeholder work is led by Luontoa consulting company that they have experience in sustainability work in mainly in forestry originally, but now also in agriculture. They did a strategic analysis of the kind of operational environment that we are dealing with in different countries, together with our local partners, and through that identified stakeholders that are most promising, most susceptible or interested or able to make a difference, and then approach those, and of course utilizing their own contacts and our partners' contacts to key stakeholders in the regions.
Great, thank you. Okay, and I actually have a question as well related to this for David with the Transform project. I was interested in your mention that farmers are less happy to collaborate, and I wondered when did you notice that shift? Is that something recent, or it's been happening over the past few years? And as researchers, what can we do to combat this problem?
Actually, as I was talking and presenting, I felt that the way that I actually presented that bit was particularly negative. I'm not actually trying to say that farmers don't want to participate, but they're actually very rather overwhelmed at the moment. But I mean, we've noticed over the last 3-4 years that there have been a number of situations where farmers have protested. They've appeared in front of the Parliament in Brussels, in Paris, and various other things protesting. They're not particularly happy at the moment with everything that's going on. They think that there's too much legislation, and they identify frankly, they identify a lot of agricultural researchers as being involved in that legislation and being involved in that kind of excess workload that they have. So we're in the strange situation of wanting to change things, trying to change things in a positive way by working with them, but actually having difficulty to actually try to engage with them, much as we'd like to. Ways of dealing with that, I think it's actually just keeping on going, trying. For example, we're trying to write our work up for agricultural journals and agricultural newspapers, things that farmers actually read, trying to actually show that this is of real benefit to people and that kind of thing. But I think it's a really important issue going forward if we're talking about working with people, working with stakeholders generally. Okay, let's move away a little bit from farmers, but whatever groups of people we need to work with to actually get sustainable, good solutions, this kind of engagement is actually in some ways becoming more difficult, or appears to be becoming more difficult, and we've got to be flexible, try new ways, what have you.
Great, yeah, thanks. Yeah, very good point, to be aware of the social, political and cultural dimensions of the groups that we work with. Okay, Tamara, Laura, I think there are no more questions, so we'll move on to the panel discussion.
Yes, you can move.
Okay, so if we can have the next slide, and the next slide as well. So we're going to have 15 minutes for each of the 4 topics. And the first topic is exploiting agroecology as an approach to enhance the climate resilience of the farming system. So we're going to ask a question for the speakers of the 4 projects to respond to. If you would like to add questions on this topic, then you can also type in the chat, and we will also incorporate it into this topic discussion. So just a reminder, the topic is about how we can use agroecology to enhance climate resilience of the farming system. So I'm going to pose a question to the speakers. What ecosystem services and ecosystem functionalities are lacking in the current agricultural production systems, the prominent production systems that we have? And what concrete ecosystem services and functionalities do we need to enhance and support to support the resilience of agriculture against climate change? So I'll open the floor. Any volunteers to come first on this question? Maybe I could go to David first, maybe, because you just spoke. Maybe you can carry on speaking.
Okay. I mean, this concrete kind of like approaches to enhance climate resilience in the future. I mean, I could respond with a number of things. We could start with a definition of resilience, either an ecological one or an engineering one. But one of the things that we're very interested in Transform is actually sort of the social aspect. One of the things that was in the original call for the 4 projects was that we would actually produce no regrets solutions. These are solutions to the problems that we have with climate adaptation, which would mean that as a society we would not be regretful of making certain decisions. And so in Transform, as an example, we're using things like the roadmaps that we're creating to actually go to society, or at least to representatives of society, the regional governments and some of their stakeholders, and actually asking, what do you want of agriculture? What are the things the targets that you want to hit to make sure that your future agriculture is resilient? Now, many of the things that they want and the things that we as scientists would say were resilient are actually overlap. You know, there are things like, you know, sort of carbon storage, fresh water, both quantity and quality. But there are other things as well that are more social or more interesting to society in a particular region that come out of actually doing it out of the roadmap approach. So I think there's both the scientific definition of resilience and what we as scientists might want, but there's also asking the public what they want, or the society what they want, and we're trying to do that through the roadmaps.
Great, thank you, David. Any questions from the audience on that, or otherwise any other comments from other projects on how you're approaching this?
I can mention that some examples from Dryad which are relevant for this topic. I think in Dryad, remember we implemented 11 MBSs, and many of them, I think, contribute. For instance, agroforestry and silvopastoral systems improve the microclimate regulation, reduce stress, and increase carbon storage. And for instance, adaptive grazing maintains vegetation cover and reduces the vulnerability to droughts and wildfire. Other example is this restoration of natural vegetation and ecological corridors. We call them natural islands. This enhances biodiversity and then ecosystem resilience. And same thing for soil management practices, the use of biochar to improve infiltration, soil moisture storage, and finally also the integrated water management also supports a more efficient use of water, and so especially in these systems where water is scarce. Yeah, so. Well, this is just some examples from Dryad that contribute to this. Okay.
Thank you, Javier. We do have a question in the chat from Aish, which is more around a question about stakeholders and how to build a strong team for projects. So Aish, I'm going to come to that question in topic 4, which is more related to stakeholders and kind of interdisciplinary work. So we'll come to your question. Anybody else would like to come into this topic? We have still a bit of time left. Any of the other projects would like to share their approaches?
Yeah, I could share my thoughts. When I think about this topic, I started thinking about functions of the ecosystem services that might have been lost in agriculture, and what we might want to enhance, and what can be enhanced. And basically, when we are doing agriculture, we are altering the natural state of the ecosystem in a very large way, in very intensive way. But we can potentially retain or return some of the services and functionalities that have been lost. Javier was mentioning biodiversity, for example, that contributes to resilience of the entire ecosystem. And also hinting towards nutrient retention and water retention, and those are like key aspects for productivity of the agriculture, but also functioning of the ecosystem as a whole. And they also provide services outside the agriculture. For example, if we improve nutrient retention in the agricultural soils, we get better productivity, but also less runoff that would spoil our water bodies. And water retention can contribute to preventing flooding, for example. And I think one interesting aspect related to resilience, climate resilience, or utilizing agroecology in general is that people quite often intuitively think that this is something additional that would need to be done on top of normal agricultural production, and might be costly or time consuming or so. Just yesterday, I was participating the EU Green Week high-level conference in Brussels, and there was a panel discussion about benefits of climate resilience solutions. And the speakers were providing a lot of good examples around Europe where applying climate resilience practices or regenerative farming practices was actually improving the profitability of the farms as companies and financially, and also well-being of the owners or workers. often the level of inputs and sometimes even level of work needed was reduced due to applying more ecological or sustainable practices, and that directly contributed to lower costs and lower workload. So agroecology can support the ecological functions, but also financial and social aspects of farming and production.
Very interesting, Karisto. I might ask you for information on that talk. That sounds very, very relevant with some good data. Okay, any thoughts from the Clean Pannonia group, maybe Maja or somebody else? Yep.
Yes, I just wanted to add in line with this thing that was already mentioned, like water retention and so on, that we have to emphasize also the importance of soil and soil health as a very not only for the Pannonian region, but more as a very important medium for entire planet, as a medium for food production. So quality of the soil we are facing that is very disturbed and degraded. So with many activities, practices, we heard about regenerative agriculture, so different practices within this approach is also important for creating one good environment for production of food, but also for increasing biodiversity and many other aspects of well-being for plants, animals, and humans as well. So yes, there is a lot of things that we can count on.
Thanks, Svetlana. That works well for our next topic. I think maybe we can change to the next slide. So the second topic that we're going to discuss is improving the resilience of agriculture and or the forestry sector, depending on your expertise, including the improvement of soil. So this focus on soil is what we want to talk about in the second part of this panel. So how can we improve resilience of the agricultural sector and the forestry sector, specifically focusing on improving soil through circular approaches? And so a couple of questions for the panel. The first is, how do forestry and agriculture interact with each other in the regions that you're working in, and how can they support climate resilience across these two types of land use? Who would like to go first?
I suppose I can start. As I said, the Boreal region is dominated by forests, so pretty much all of our farming is very closely linked to forestry. The fields are surrounded by forest areas, and they are very much interacting. As forests and farms are so closely linked in the region, they really interact with each other. And one obvious way is the water dynamics. So practices that are done or management that is done in the forests directly affects amount and quality of the water that is coming to agricultural grounds. And there are also very direct links from forestry sector to soil health in the farmlands, as we are using pulp mill sludge or the pulp leftover pulp from forestry for improving the soil health and soil conditions in our soils, agricultural soils. The question is related to pulp and other soil improvers, whether they are actually beneficial everywhere or where should they be applied for most benefits, because there are huge differences between different agricultural soils, between regions and within regions, how degraded the soils are, what kind of qualities the soils have. And I would be interested in hearing perspectives and experiences from our sister projects related to that.
Great, thank you. Any responses to that from the sister projects?
Well, I can say about the Clima Pannonian generally. For the Pannonian region, yes, it's a more or less flat area where in previous times we, as an example of doing together agriculture and forestry, is that we in previous times had a lot of zones with windbreaks or like a trees for the purpose of reducing the wind affecting the soil and soil erosion. However, that kind of practices it's not so present anymore. So the soil is very exposed to different types of degradation, but that is not only the thing that we can provide from the forestry in combination with agriculture. So there is also the water retention, the biodiversity, the pollinators number is increasing, and within Clima Pannonia, one of the solutions is combination of growing using trees for berry production. So in that terms, agriculture and forestry works very well together. So all those benefits that I mentioned, and in addition with shade, creating a shade for the plants, for the berry, and also like a microclimate for them, it's something that it can be worked and can be applied. So not only to count on the windbreaks, but also as this kind of combination and solutions, of course.
Maybe I can comment if Jara, I don't know if there are questions or comments on this, but I can
go ahead.
Yeah, okay. I can comment some examples of how in Dryad we have implemented MBSs to improve or to improve resilience and closely related to soil, right? So remember, in my presentation, we divided the MBSs and grouped them, and one category was the soil related and MBS, and that included one of them is wildfire prevention. Wildfire prevention is essential to ensure the health of the soil, obviously. Now also the adaptive grazing, okay, which means you move the cattle around in a way that you don't exhaust the soils and the vegetation. So it's in a similar way. We also have another solution which involves the real-time monitoring of livestock, and again with the idea of optimizing or the location of the cattle. Then we have the other, for instance, such as biodiverse pasture sowing, and we also incorporate something that might be a little bit controversial, is the use of biochar. Okay, so I don't know if I should touch this topic, but some people argue that biochar is question that if this might not be a natural based solution, a nature-based solution, because it's an artificial, it's based on an artificial product. Anyway, we consider it as an NBS, and it's the idea is to improve the health of the soils, improve water content, and improve also biodiversity. And this is we have groups quite very strong on this with a lot of experience, and actually we are excited about the outcomes of these MBSs, of this MBS. Okay, so so the message is, can we improve? Yes, at least in the Mediterranean region, we managed to identify 1, 2, 3, 4, 5 of them. We will see how efficient and how, to what extent, and this is the key idea of demonstration. Let's see, some MBSs may be more successful than others. Okay, so.
Thanks, Javier. Yeah. So we have some hands up from, I don't know if that's in response or to add some additional info on this topic. So I think David was first.
It was sort of on the topic. You originally asked the question, Yara, of the relationship between forest and more kind of like agriculture, forest and agriculture. We don't work with forest at all in Transform. Ours is purely about crop rotations and sequences of crops in fields and then scaled up to larger scales. But in terms of resilience, what we're doing is trying to predict from a sequence that farmers conceive what the consequences of that are for a number of different indicators and services. So we've got economic services, we've got environmental services, including certain indicators about biodiversity. We've got agronomic ones and we've got social ones. So we're trying to predict, and using, sort of like a sort of scientific criteria, what is the resilience of those services if we adopt those rotations in the future. But there's also the aspect of taking it then to stakeholders and actually presenting those results to stakeholders and actually asking them what do they like, which combination of economic, agronomic, environmental and social do they like, and which would they choose. And that allows us to order those rotations that farmers conceive that could contribute to a resilient future. That's the way that we're choosing to do it. But we don't work with forest, and that includes certain things like water and soil and so on and so forth.
Thanks, David. Yeah, and it's one of the reasons why it's useful as well for us all to come together as sister projects across different regions is that there are parallels as well in some of the questions that we are asking. So as Javier was mentioning in the Dryad project, we've reached the stage of analysing more the kind of, I guess, physical aspect of the MBS and what can and can't be implemented. But I know that there's a lot of work happening in the next couple of years on the socioeconomic indicators linked to those MBSs and whether they can and will be adopted. So interesting to carry on comparing across the different Atlantic and Mediterranean regions and seeing what we find. Great, we have a hand up as well from Brazilia's project, Caristos.
Yes, I wanted to touch the comment from Javier related to biochar, because I think that's very nice example about solution that might be very useful in some regions and not so much in other regions or specifically on certain fields. Here in Finland, we have a lot of biochar available easily because of a lot of forests, and it has been tried on many places, but we quite soon run into observation that adding biochar to our soils does usually not change much, because we have quite a lot of organic soils already, and we even have trouble with climate related to organic soils, because a lot of our agriculture is done on peatlands, and we have quite an opposite problem, that we have so much carbon in our soils that we have to actively develop solutions for preventing loss of that carbon, to prevent carbon dioxide formation in our soils. So it's just an example how totally different the conditions might be, and how different solutions might not be suitable everywhere. And I think that's one of the big reasons why the mission is emphasizing regional approach and locally tailored solutions for improving exactly the conditions that occur in each region. And if we speak about soil improvers, there is some of course some selection there. We have been doing some work related to gypsum, for example, as a soil improver that might be more relevant to us, keeping phosphorus in the soil and stabilizing the structure.
Thanks, Pedri. I remember that your name is Pedri and your surname is Caristo. Sorry about that. That I was calling you by the wrong name. Javier, did you want to respond to Pedri?
Just a comment you touch. You brought a point. I think it will come later in topic 3, but it's about whether solutions could be replicable or applied to other regions. Okay, and you gave just an example, right? A biochar, but then. Still, even if you cannot translate the solution, maybe the approach can be transferred. We will discuss this later. Yes. Okay.
Great. Okay. So no questions yet. We have a shy audience, or maybe, the conversations we are having are so interesting. There's no further questions to ask. So please do keep asking questions. And I know that we have, I think we have the project officer from one or some of our projects here as well. So if they would also like to ask a question, then please let us know. Great. We'll move on to topic 3 then in the meantime. So, and just to say, some of the topics that we've chosen for the panel as well are answering the key aims of what this call required, right, from the projects and from the research. So we're trying to kind of frame the questions that were asked of us from the Commission and how these have been addressed by the different projects. So the third topic is development of more natural ecosystems, generating combined benefits for climate mitigation. Some people have already mentioned, can we measure the benefits of these different approaches? And here we want to spend some time thinking a bit about what these natural ecosystems look like and what different types of benefits they can provide. So I'm going to pose a question of how do we perceive natural systems in agricultural landscapes? Natural systems can be viewed very differently by different regions, different communities. And are there some examples from the projects on how you are measuring the different benefits of these natural systems? Pedri, would you like to go first? Your hand is up.
Yeah, I think I can continue the earlier discussion or from Javier's comments also on this topic about applying the same principles or solutions for different purposes. One solution that has been largely applied in Finland for mitigating carbon emissions is controlled drainage on peatlands. Basically, we need drainage to get rid of the excess water, but if we dry the peatlands too much, the carbon emissions increase. So we have controlled drainage where we can stop the drainage or even pump water back to the fields to keep the water levels optimal. And while this solution was developed for the emission mitigation or control purposes, it's been now applied on mineral soils for improving resilience of the production, improving water retention in the fields, and to improve productivity. So that's kind of nice example of a crossover from combating climate change, but also creating climate resilience.
Thanks, Pedri. Anybody else would like to answer or add any thoughts on this topic of how we view natural systems and what their potential benefits are? David, yeah?
I could say something. I think agriculture is an exploitative system. It's not a natural system. We, as human beings, we manipulate this system to give us some of the things that we want, whether that's food or fiber or whatever. But we also know that if we stop doing agriculture and our agricultural landscapes return to some sort of wild state, that people also often don't like what happens to those abandoned areas. We have a number of components of biodiversity in agriculture that are really, really emblematic and people like and want to keep. And so I don't think we should think of agriculture as a natural system or a natural ecosystem, but it's certainly an ecosystem we want to conserve, preserve, improve going forward. The way in Transform we're trying to do that is that we know from a lot of ecological and scientific research that if we increase the diversity of cropping in systems, we can actually get some things that we really rather want. We can improve the situation and the ecosystem delivery in those systems. So by trying to invent or innovate new rotations, we hope to be to also in each of our regions increase the diversity of cropping in those regions so that we actually get out of those regions more of the things that we want from agriculture.
Great, thank you, David. Yeah, difficult to think of agriculture as a purely natural system. I guess we've been, probably not, maybe surrounded by some natural systems in some cases, but definitely a gradient. Javier?
I want to comment on this issue of what is natural, what about agriculture. I think, Dave, your point, I agree fully with your statement. So the issue is not either natural or agriculture. Preserving nature, or you may call it naturalness, should not be an objective itself. Okay, so we have agriculture, so we should look at it at preserving the ecosystem. So is actually the goal should be more the maximizing resilience and biodiversity and sustainability. And let me add on this, and this is probably not very well known. Our ecosystems, we call them dehesas in Spain, montados. Again, this type of, as you can see, the background of my background is this type of landscape. This is not natural. This is man-made. Okay, I mean, it has been like this for probably a century or so. So this is an example of how we can preserve the nature in a way that is I don't know how to call it, but that is combines very nicely the use by humans and preserving the nature. So that's my comment on this.
Thanks, Javier.
Yeah, I'd agree very much with what Javier says. A lot of the economic activity of Europe is quite a lot of economic activity in Europe is linked to our landscapes. I mean, a lot of the tourist industry is linked to these landscapes. As I said, they're not strictly natural ecosystems, they're exploited ecosystems, but they are something we want, and we want to maintain them and keep them because we find them beautiful, and they're part of our history, and yes, so they need to be conserved.
Definitely. And Javier, I think the example of the Mediterranean savanna, as I call it, is an interesting one, because it's different to some of the agricultural landscapes that David maybe is talking about, or the forestry landscapes in Finland. But these are cultural landscapes that have been modified by humans and nature for thousands of years in some cases, and so natural systems and agricultural systems as well are shifting baseline of how people perceive them, I guess. So very interested to have all of your different landscapes represented here in the different projects in the different regions.
Yeah, if I may, Jara, okay, Petri, you mentioned another example, of solution which I'm sure is very specific of the boreal conditions. The drainage of these peatlands, which are not very common in, I would say, in the Mediterranean region. Okay, so then the implementation, demonstration all our sister projects, we must address or demonstrate NBSs, but the design probably, I'm sure, is region specific, probably site specific, okay, because the soil, the climate, water availability, and so on are quite different. Okay, now what I think is common is the principles, the approach, the techniques, the how we combine, for instance, stakeholder engagement. That doesn't it may depend also on climate conditions, but humans are humans. Okay, so I mean, and willingness to implement solutions for those aspects, principles, the techniques, those, I think, regardless of the climatic conditions, I think we should converge. So different regions should converge on that. So, the mechanisms, I think at the end, we are working on the same thing, improving soil health, reduce drought vulnerability. I was very surprised that you, in your project Resilience, you are now considering this as an MBS to deal with droughts in your regions. So that's it's a very good example of how there might be differences, but also similarities in the MBSs. So,
thanks, Javier. Yeah, very great, good points. And I think I'm going to go to the chat because we have a few questions. One of the questions is from Aish Kumar. And again, this relates to your point, Javier, around different regions, but similar potential methodologies. And the question is a practical question. What is the ideal team formation for these projects? What constitutes a good team in terms of being able to deal with all these different interdisciplinary needs of NBS research and implementation? So which technical skills do you need, such as modeling, etc., but also what other skill sets are maybe needed for narrative building, for stakeholder management, for long-term sustainability of projects? So the question to each of the panels on your thoughts on what team members and which skill sets are needed in these projects.
So this is a question for any particular project, or
or any of the projects. David, if you would like to go first, your hand is up.
I was just going to say the way we approached it. We tried to think of how we were going to deal with a complex problem that involved numbers of different stakeholders, all of whom might have different opinions, and those opinions being a potential source of conflict. On the academic side, we very strongly went towards a mixed group of academics. So we have some natural scientists who make predictions, the modeling side of things. But we also have a large group of economists, social scientists, and even sort of psychologists of innovation in the project. So there are people in the project who actually deal with these questions of innovation, transformation. On the other side, we explicitly at the start of the project decided to take on board as partners people who actually work in agriculture and who deal with regional governments. So as I said in the start of my talk, in each region we try to have an academic and a practical partner, and that was the major way that we approached it.
Thanks, David. Petri?
Yeah, we are tackling really complex challenges and complex issues, and that quite easily leads to requirement of very complex expertise in the consortium. And although sometimes we might feel as coordinators that we need to be able to answer all those complexities to some extent ourselves. We are really thankful for the consortia and the expertise that we have, and we also have really diverse set of partners in Resilience. It's really wonderful to work with all the different experts And I think a key aspect to well-functioning team is the aspect of trust, and that is also key in really advancing the adaptation and getting the solutions to the field, getting them adopted by practical people. And one contributor to trust is proximity, whether it's spatial proximity or kind of a mental or cultural or expertise wise. And there's a lot of diversity in all of our projects, and I think we have all hit into the situation where when different experts are trying to understand each other, it might be difficult. We might deal with different terminology, and in that sense, it takes quite a lot of work to build trust and mutual understanding of what we are doing together. And the same goes to our stakeholders. We have to have enough people in the consortium, in the project team, who understand our stakeholders, who can speak the language of the stakeholders, and who can efficiently recruit participants to the project that understand, kind of translate the academic thoughts into practical language. And we are doing explicitly that in Resilience by building the climate impact narratives, trying to translate the scientific knowledge to practical language and practical context. And one particular thing about this call was the focus on biogeographic regions, which I think is very good one, so that our consortia are quite well comprised within limited spatial area. We are kind of close to each other. It's easier to interact. It's easy to see each other and go for different demo sites and so on. And I think that's one major thing as well, contributing to trust within the consortium.
Thanks. Yeah, I agree. In this online world, there is still so much value in getting together in person and experiencing things in the actual landscape. So yeah, thank you very much. I'm just going to read another comment that we've had come through, and then if any of the other projects want to participate, then please do so. So we have a comment from Giulia Moretto from CINEA, who says, thank you for the interesting presentations and the panel. And she asked a question related to transferability of results, which we were discussing earlier. So since we are all tackling different regions in the EU, one of the challenges is the applicability of different solutions in other regions or other ecosystems due to differences of their components, such as soil, geomorphology, weather, etc. So what are some of the pathways that you each think could work to achieve transferable results, and can we have standardized ways to measure the collective positive impacts of these projects? So yeah, she mentions joining efforts across sister projects is already a great start, but are there any thoughts on how we can transfer some of these results, but also how can we standardize a way of measuring collective impact of this research all across Europe? Javier?
Yeah, maybe I can give a first answer to this question. I think it's a very good, a very important point, actually. Yeah. Now, let's go by steps. I think all the projects involve demonstration and replication, and replication is meant within the same region. Okay. So in our case, in Dryad, we have 5 demonstration regions and 3 replication, and one of them is not exactly the same landscape. Okay, it's south of France. It's not entirely the same. It's not oak trees, it's pine trees. So it's a little bit, but still Mediterranean. Well, first, before we think about the transfer from solutions in a given region to other regions, maybe we can first answer the question on how to replicate. We call it replication. Yeah. Now, for replication, Well, replication, as you can expect, is an activity that comes not at the beginning. Once you demonstrate, you replicate. But at least in our project, we consider we will develop a replication strategy. We have already a draft plan for replication, and our experience maybe we have 3 replication regions, and most of them are very good replication cases. So they are very good students, very good because they have already a lot of interest. And okay, so but what we are seeing is okay, just to give you some examples for replication. It helps if they are involved in the process of demonstration, and then we consider the creation of a community of practice. Okay, so there will be we are initiating this community of practice in which we have the replication regions. I'm sorry, the demonstration regions, the replication regions, and key players in the project, and this will develop first the plan and then implement carry out the implementation plan. So I think we have a roadmap already, a draft for the replication. Okay, now the experience on going from demonstration to replication should provide a lot of insight on how to go one step beyond. So solutions that have worked nicely in Mediterranean could be transferred to Pannonian region or to other regions. That is something that, of course, the European Commission is really interested. And my view is that in principle, it would be a step forwards, but with a lot of experience in doing from demonstration to replication.
Thanks, Javier. Thank you for that. Svetlana?
Yes, thank you. I just wanted to add to the things that Javier said. It's very important that this project have not only demonstration but also replication sites. One of the ways to transfer the solutions and to achieve more transferable results. I must say that it's very important. For instance, for the Climate Pannonia project, that we have replication sites not only within Pannonian region but also beyond. So all solutions are testing in different environment totally. So like a climate, soil conditions, crops that are growing. So in that way, we can analyze and validate proposed solutions in totally different environment. So that is the, I must say, like a one step forward, and the way how to achieve the more relevant results and for the solutions, and to find like a wider application of solutions in different agriculture subsectors. For instance, as we have organic crop production as well as cattle production, where are testing different, demonstrating different ways of sources of feed. So that is also a thing that can be transferable in the areas that are not currently and only explicitly for the region that our projects are on.
Great, thank you very much. And we'll take a last comment from David before we move on to the next topic.
I was just going to say that it's a really interesting question, and I think, I don't know whether it's the same for the other projects that are here, but amongst the partners of the Transform project, there's quite a diversity of opinion. You know, there are partners who believe in genericity and that we can actually do work that's applicable to all regions, and then there are other people who believe that their region is the most important region in the world, and the things that happen in their region only happen in their region. It's kind of an interesting and dynamic tension, and actually that's the whole point. What we want to do is across Europe is to actually sort of like have some kind of unifying principle of belief that we can probably legislate at some sort of international level for certain things, but that then we descend some of the work down to the regional levels because we want local solutions for local people. We're trying to incorporate this into things like the roadmap methodologies so that you can actually build on a generic framework, a way of building a set of targets for your region, but which allows us to bring in regional kind of like specificities and differences and so on and so forth. We also have the modeling side of the project, which is this sort of attempt to predict from field scale to regional scale for multiple different regions, economics, agronomics, social effects, and environmental effects. And we already know from some of those models that they work in many regions of Europe. They're already generic in some senses. So we believe that this sort of side of things. But the main way of doing it is actually going, and as Javier and as Svetlana said, using methodologies like the demonstration regions and the replication regions, which may be similar or may be very, very different from each other, to show that the methods that we create actually are transferable and thereby extrapolable, at least in principle, to other regions of Europe.
Great, thanks, David. Yep, getting some thumbs up. So thanks very much for all the different responses and the different opinions on how to scale the results and how to share results across Europe. Very interesting. So we go to the last topic, please. Next slide. The last topic is demonstrating and increasing awareness of the value of maintaining and restoring existing natural systems. And we have a question related to this already from Bruno, I think. The question is, what are the key barriers to scaling up natural ecosystem restoration for climate action? So this, again, question to any of the speakers on the projects. If you're touching on this in your project, what are the key barriers to scaling up natural ecosystem restoration around agricultural production and forestry production, I guess? Anyone want to respond? David?
We've sort of touched a little bit on this in earlier responses. I think the clear thing for me is that we operationalize that question in some senses. What I mean by that is that we actually sort of like say, what is it that we want to restore precisely? Because we've actually got quite a lot of agricultural research, some of it in the projects here and some of it in the literature, that shows that if you've actually got a clear target, we actually can often hit it. We can actually do something about it, and we can also demonstrate that we can work with many of the stakeholders involved in that and actually do things. But it's important to actually really be clear about what you're actually trying to achieve in your restoration. What is it? What restoration it is you're actually dealing with? It's not some sort of large scale sort of wishing to turn the whole world back to something like 1820 when everyone was happy and all that kind of stuff. It's actually something that's targeted and specific and we can actually aim at.
Thanks, David. Svetlana, do you want to come in on that as well?
Yes, just to add, yes. Well, when we talk about barriers and make it like agriculture more naturally, yes, depends, of course, on the agricultural subsector that we are talking about. But if we talk about like field crop production or agroforestry, we will definitely need to start from the involvement of the farmers, that the primary participant in that agri-food value chain. So if the farmers or the producers are not willing to accept some, or not able to accept some solutions, or to scale up their natural ecosystems, or implement something, that is a very first barrier that we are coming into. So, but definitely, it's not only on farmers, it's not only on producers, it's a combination of different stakeholders. They need to be actively participate in this scaling up. So this is something that I can add to the David's.
Great. Yeah. So we have understanding what the restoration aims are, and also understanding who that restoration impacts, and how to mitigate any consequences, and involve the stakeholders in a fair way. Thank you. And Javier, comments on this question: barriers to restoration around agricultural systems?
Well, well, I'll give you the examples that of natural ecosystem restoration in Dryad. So basically, our MBSs will contribute to restore degraded soils, enhance vegetation cover, improve the ecological connectivity, to promote agroforestry systems, by forestation, okay, in areas where, remember, we have tree mortality as a serious concern. Again, adaptive grazing management to preserve the good soil conditions and avoid land degradation. So we have very good examples of ways that will prove that this is indeed in this silvoagroforest for agro-pastoral systems will work. Okay, so these are some examples. Yeah.
Brilliant. Any last questions from the audience before we move on, or any last comments from the panel on this fourth topic? On increasing awareness of the value of maintaining and restoring systems. If not, I think we don't have any more questions. Laura, Tamara, no more questions? So, okay, yeah. Two more panel participations. Go ahead, please. Yeah, but then you can start.
Okay, yes. Yeah, when speaking about restoring natural systems, I think it's very important to really define what we mean about that, and I think that comes close to what David said earlier, that we have to be specific about the goal that we are aiming for. As discussed earlier, all agriculture and also forestry means pretty strong alteration of the natural ecosystem. There is very little pristine natural aspects of our primary production. But then if we want to make them more natural or natural-like, then it's a big question of what do we actually want to achieve, and why do we want to achieve it. I think from a production perspective and resilience of production, we want to have more natural dynamics or aspects of the production systems for the benefit that it creates to the production, so for the instrumental value. But there are a lot of people who would like to have more natural ecosystems for the intrinsic value, just to have actually natural ecosystems, which is of course really difficult to achieve, but it's a key aspect also on acceptability of primary production and how people see it, and of course contributing to tourism, for example, and so on. So it's very complex. It's very complex question about how to measure naturality, or how to achieve that. And related to Julia's earlier question about how to measure the positive impact of the projects, I think it's very hard to achieve anything that would kind of in a generalized and comparable way measure our impacts, because the solutions and interventions that we do vary a lot, both on the depth or strength of the intervention, but also on the area that we are applying them on, and also on the strength of the effect that they have on the system. So it's very difficult one, but maybe comes conceptually close to discussion about nature credits, which is kind of way of trying to uniform or make a baseline measure for value of different actions.
Great, thanks very much. And before I give the floor to David and Javier, I'm just going to read another comment or question that's come through, rather, from Julia from Cinea, in case you want to incorporate that into your comment. So Julia asks, have you encountered any challenges in your project so far related to increasing awareness of the importance of preserving and restoring existing natural systems? And have you encountered any challenges with specific audiences, for example, public authorities, general public, the private sector, etc.? Yeah, David, go ahead.
Could I answer that one, and also answer something that I was going to say about the awareness side of things? But one of the things that was really interesting in the actual mounting of the project, or the creation of the project, is that there's the charter which regional governments and regional authorities are supposed to have actually signed into to actually take part in the mission climate adaptation. But actually what we found was, when we approached many of these signatories to the charter to actually play a role in the project, it actually became quite difficult to get them to be involved. Many of them actually have a limited, particularly in agriculture, a limited set of policies that they're actually pursuing actively. These might be water, these might be pesticides, they might be whatever in their particular region, but it's not yet climate change. And so actually it's quite difficult to engage, even though the regional partner the regional government might be interested in some senses in climate change. They don't actually yet have active policies, and it's difficult therefore to engage with them. So that's probably one of the biggest things that we've found difficulty with, is actually engaging with the regional governments to actually get their involvement in the project, or actually go and talk to them, and so on and so forth. But I'll shut up and I'll come back to the I wanted to say something about awareness and some of the public kind of work that we're doing, trying to raise awareness amongst the public about rotations. But I can come back to that later if you want, or I can do it now.
Javier, is your question related to Julia's question? Because otherwise we might let David finish his comment.
Yeah, I was my comment is about the question of Julia, which challenges, to me, one of the main challenges is stakeholder engagement. Okay, so and Dave mentioned this. So, and this was one point I wanted to bring before we close the session, because I think stakeholder engagement is the key for success. Okay, because and it's not a matter of counting stakeholders; it's a matter of measuring the influence that we are able to they are able to play. Okay, so they shouldn't be just the end users, but and in our case in Dryad, they are part of the co-creation. So of course we found difficulties. We performed an online survey, and there were more responses in some regions than others. We learned some. We know we need to promote, because they lack sometimes interest. So we need to include incentives. Okay, so for instance, demonstration sites have a lot of potential. So if you take stakeholders to a site where you can show how performing or after implementing these MBSs has improved things, that's the best way. And I should say this, that we visited, I mean, the coordination team, we visited all the demonstration regions. We visited some of these farms, and we were really impressed. So I guess stakeholders, but there could be other. You may need more incentives. So again. Coming back to the question of Julia, there are many challenges, okay, but probably for us at the research centers or at the universities or companies, or the key is stakeholder engagement, okay? And unfortunately, we have in our consortium, we have groups with a lot of expertise, and Jara, our chairman today, she's expert on that. So that's it, stakeholder engagement.
Great, thanks, Javier. So we'll come to Svetlana, and then we'll end with David as our last comment.
Okay, thank you. I just wanted to add that, well, the challenges are also present, but it depends if our farmers are ready to make some changes in crop production, in cattle production, also in fruit, but for some, but they need more support, more understanding of local or public authorities to implement something, because for instance, for some practices or some solutions, they need to invest some money, some effort and the benefits are coming after several years. Also, I think that the important is to increase awareness among the final consumers, also to know the benefits of this kind of approach in agriculture. So this is very shortly.
Thank you very much. And final thoughts from David.
Going on from what Svetlana just said, I mean, one of the things that I said in my talk is that, with the change in rotations that might come with climate change, we're going to see a change in our landscapes. The impacts on wider society will be felt not just through the food that they eat or the price of that food. It will also be the way that the landscapes in which they live actually will change. So we've spent quite a bit of time doing things like creating VR presentations that people can actually enter into landscapes and look at different landscapes. We have at least 2 games in the project which are designed to be played by something like 10 to 15-year-olds or 3 to 6-year-olds, depending on the game, which tries to actually show that the sequence of crops that we use is really important for the food that we eat, for the way things look. There's the game that's been created for really rather young kids is a tile matching game, which has foodstuffs and the crop, and we try to match those things with an aim to actually try to raise awareness amongst the public that these rotations that farmers are going to create are going to impact you, that they could impact you negatively, but they could also impact you positively, that farmers have a difficult job to do, and so on and so forth. There's a way of trying to actually increase awareness about farming and landscapes and the future.
Thanks, David. To end on that very interesting positive note of new ways of engaging people. Thanks very much for that. Okay, so if we could have the next slide, please, and we will wrap up the session. So thank you everyone so much for joining us today. I've really enjoyed it. I hope you have as well. We've learned a lot about all these different projects and the work that they're doing. These projects are ongoing, so please do follow them on all of these different channels so you can continue to find out what the projects are working on as the results come out. So we've shared here the information, the websites of each of the projects, social media handles, And just to say a big thank you to everybody for joining us today. Thank you to the 4 projects, Klima Pannonia, Dryad, Transform and Resilience. Thank you to the speakers. Javier had to rush off, so thank you to Javier as well, and hello from him and goodbye. So yeah, we've hopefully given you some important information and useful information on all of these research projects and what they are advancing in terms of climate resilience in agriculture. So we'll be sharing an email with all the participants that will include links to the recording if you want to look at the session, and also the information on the projects if you want to follow them. So that's it from us, and thanks again everybody, and have a good Friday and a good weekend.
Thanks, Yara.
Thanks everyone. Goodbye.
Thanks everyone.
Thank you.
Bye bye.
Bye bye.
Bye bye.